So the big picture for this lesson is polynomial division. And we're going to be doing some division because next thing you're going to learn is about factoring polynomials in different ways. And the techniques you're going to learn here are going to help you with the factoring that's coming up next. So let's start with a polynomial. Let's say f of x equals 3x to the fourth minus 2x to the third plus 3x squared, and then minus 4. And let's say I want to divide it by g of x, which is x minus 2. Now there are two different ways to do polynomial division. One way is called synthetic division, the other way is called long division. Let's look at synthetic division first. Synthetic division can only be done if you have two terms like this, a binomial. And so it's just simple, like x minus 2, x plus 4, that type of thing. So what you do is you do the same thing as synthetic substitution. You list the coefficients, 3, negative 2, 3, and 0 for the missing x term, and then negative 4. And then what you do is you draw your little bracket, and then you put 2 right here. If you're dividing by x minus 2, you put a 2. If you're dividing by x plus 6, you put a minus 6 here. Okay, so then you go through the process. Bring down the 3. 3 times 2 is 6, so the 6 goes here. Negative 2 plus 6 is 4. 4 times 2 is 8. 8 goes here. 3 plus 8, 11. Multiply. 2 times 11, 22. Add. 2 times 22 is 44. Add to get 40. Then what you can do is you get your quotient, which is your answer that you get when you divide. This 40 here, this is the remainder. And this is going to be the ones place, the x place, the x squared place, the x to the third place. And you have x to the fourth dividing by x, you should have x to the third. Okay, now these aren't fractions, I'm just indicating where the places are. So the numbers here are the coefficients. So it's going to be 3x to the third plus 4x squared plus 11x plus 22 plus, and then the remainder, you write it as 40 divided by x minus 2. Okay, so that is synthetic division. And you'll see a lot of other examples in the lesson. Long division is a bit longer process, just like the name. And long division doesn't have any restrictions. You can divide by any polynomial. So if you're dividing by an x squared or that type of thing, long division is your way to go. So let's divide 3x to the fourth minus 2x to the third plus 3x squared plus 0x minus 4 divided by x minus 2. So then you just do like a regular long division problem. You need to figure out how many times x goes into 3x to the fourth. And it is 3x to the third times. Because if you multiply 3x to the third times x, you get 3x to the fourth. So then multiply. 3x to the third times x is 3x to the fourth. 3x to the third times negative 2 is negative 6x to the third. And then you subtract. Negative 2x to the third minus negative 6x to the third, that's like adding, so you get 4x to the third. And then these cancel out, 3x to the fourth minus 3x to the fourth. Then bring down the next term, plus 3x squared. And then you see how many times does x go into 4x to the third? Well, it's plus 4x squared. So then multiply. 4x squared times x is 4x to the third. 4x squared times negative 2 is negative 8x squared, parentheses, and subtract. 3x squared minus negative 8x squared, that's plus 11x squared. 4x to the third minus 4x to the third is 0. Then bring down the plus 0x. How many times does x minus 2 go into 11x squared? It's plus 11x. 11x times x is 11x squared. 11x times negative 2 is negative 22x. Parentheses, subtract. 0x minus negative 22x, that's plus 22x. And then the 11x squared minus 11x squared is 0. Bring down the negative 4. So 22 goes here, plus 22. 22 times x makes 22x. 22 times negative 2 is negative 44. Subtract. Negative 4 minus negative 44. That's the same thing as adding 44, so it's plus 40. And then 22x minus 22x is 0. So you get the same thing here, and you write your answer the exact same way. The remainder is written as 40 divided by x minus 2. So that's long division. So study the examples for both of these techniques in the lesson, and you'll have plenty of practice as well. That's the big picture.